We now discuss the solution of a problem from the section complex numbers. The problem is related to the intersection of mod z is equal to 3 and the argument of z minus 1 minus argument of z plus 1 is equal to pi by 4. This question has appeared in the joint entrance examination main held on 29th June 2022 in the second shift. The given question is, let argument of z represent the principal argument of the complex number z, then mod z is equal to 3 and the argument of z minus 1 minus argument of z plus 1 is equal to pi by 4 intersect. We are given four options. Option A, exactly at 1 point. Option B, exactly at 2 points. Option C, nowhere. Option D, at infinitely many points. And in this question, the argument of z represent the principal argument of the complex number. That means the argument of z lies between minus pi and plus pi. Then required to find the number of points of the intersection of mod z is equal to 3 and the argument of z minus 1 minus argument of z plus 1 is equal to pi by 4. We now discuss the solution of the problem in detail. We are given mod z is equal to 3. Squaring on both sides, mod z square is equal to 3 square. Writing x plus iy for z, will get mod of x plus iy square is equal to 3 square will imply mod of x plus iy whole square is x square plus y square is equal to 3 square. This is a circle and let us represent this one by C1. It is a circle with center at the origin and a radius 3. That is x-axis, that is real axis, imaginary axis, the origin and mod z is equal to 3. Agreed. Now, we are given argument of z minus 1 minus argument of z plus 1 is equal to pi by 4. This is same as argument of z minus 1 by z plus 1 is equal to pi by 4. And this is a very well-known result. Very well-known result. What this represents? And this represents a segment of a certain circle C2 in which the chord joining 1 and minus 1 subtends the angle pi by 4 at every point on the segment. So it represents the segment of a circle, certain circle C2, in which the chord joining 1 and minus 1 subtends the angle pi by 4 at every point on the circular segment. Agreed? So that is the very well-known result what we have. Now in this we said certain circle C2. Then what is that circle C2? We want to find. So we will now find the equation of the above mentioned circle C2 in the next slide. So we take argument of z minus 1 minus argument of z plus 1 is equal to pi by 4. And for z, let us write down x plus iy. So we write, then we get this one. This will imply argument of x minus 1 plus iy minus argument of x plus 1 plus iy is equal to pi by 4. So the real part of this complex number is x minus 1, the imaginary part is y. The argument will be the tan inverse of the imaginary part by real part. So that will be tan inverse of y by x minus 1 minus, similarly here, the tan inverse of y by x plus 1 is equal to pi by 4. And we know tan inverse of A minus tan inverse of B, we know the formula. That will be tan inverse of A minus B by 1 plus AB. So, tan inverse of A minus B by 1 plus A into B is equal to pi by 4. Let us simplify. Take the LCM. The LCM is x square minus 1, both in the numerator and denominator. That will cancel. After taking the LCM, it will be y into x plus 1, that is xy plus y, minus y into x minus 1, that is minus xy plus y, by LCM is x square minus 1 plus y square. That is equal to pi by 4. In this, xy cancels, and this is tan inverse 2y by x square plus y square minus 1 is equal to pi by 4. That will imply 2y by x square plus y square minus 1 is equal to tan pi by 4, that is equal to 1. Now cross multiply, we will get 2y is equal to x square plus y square minus 1. Agreed. Simplify, we will get x square plus y square minus 2y minus 1 is equal to 0. What is this? This can be written as x square plus y minus 1 whole square is equal to root 2 square. Adjusting the terms. So what is this? It is a circle with the center at 0, 1 and a radius root 2. Radius root 2. Therefore, the above one, argument of z minus 1 minus argument of z plus 1 is equal to pi by 4, represents the segment of the circle that we said in the last slide. We said certain circle. That certain circle is C2, given by x square plus y minus 1 whole square is equal to root 2 square, in which the chord joining 1 and minus 1 subtends the angle pi by 4 at any point on the segment. Agreed. Now, so that is the discussion. So, some students will answer the question from here. How? Now, they take C1 and C2. They see what are the centers. The center for C1 is 0, 0. The center for C2 is 0, 1. And R1, that is the radius for C1, is 3. And the radius R2 for this circle C2 is root 2. Then we apply the formula. That is the distance. Observe that the distance between the centers of C1 and C2. What is center for C1? It is 0, 0. Center for C2 is 0, 1. What is the distance? The distance is 1. And that is less than mod of R1 minus R2. That is 3. R1 is the radius of the C1. R2 is the radius of C2. That is 3 minus root 2. 3 minus root 2. So, 1 is less than 3 minus root 2. This implies C2 completely lies inside C1. So, this is the result what we are using, and C2 completely lies inside C1. Therefore, C1 and C2 intersect nowhere. They do not intersect. They do not intersect, neither they touch. So, C1 and C2 intersect nowhere, and that is precisely your option C. That's your answer. Agreed. Agreed. This is one way of doing things. But I will also discuss the analytical reasoning. Analytical reasoning means from the equations we argue. We put a logical argument and say that they do not intersect. So now what we say is, so C1 is x square plus y square is equal to 9. C2 is x square plus y square minus 2y minus 1 is equal to 0. So assume that C1 and C2 intersect. Then where do they intersect? We want to find the coordinates of the points of intersection. Let's see that. So then x square is equal to 9 minus y square from C1, and from C2 x square is equal to y square minus y square plus 2y plus 1. Equate them. Then you get an equation in y. 9 minus y square is equal to minus y square plus 2y plus 1. Minus y square cancels, and you will get 2y plus 1 is equal to 9, and that is 2y is equal to 8, that is y is equal to 4. Let's go back to the equation of the circle C1. So in that we substitute y is equal to 4, x square plus y square is equal to 9, and y square will be 4 square, that is 16. Then x square will be 9 minus 16, that is minus 7. Now, do we have a solution, a real solution? That means a solution in real numbers for x square is equal to minus 7? No, no real number satisfies this equation. So note that the equation x square is equal to minus 7 has no solution in R. That means our assumption that C1 and C2 intersect is not true. Is not true. So this will imply the circles C1 and C2 do not intersect at all. So that they do not intersect also involves the concept of no touching also. So that means mod z is equal to 3, and the argument of z minus 1 minus argument of z plus 1 is equal to pi by 4 intersect nowhere. That is precisely your answer. That is the answer given in option C. And that is the detailed discussion of the question. There is one more method. People sometimes draw the diagrams. So the diagrammatic method. So we have C1, and that is C1 is x square plus y square is equal to 3 square. That is a circle with the center at 0, 0 and the radius 3. Agreed. Now, the argument of z minus 1 minus argument of z plus 1 is equal to pi by 4. And we have seen that is the part of this circle, the part of the circle C2, x square plus y minus 1 whole square is equal to root 2 square. And that is the center 0, 1, and the radius is root 2, and the chord joining minus 1, 0 and the point 1, 0, the chord in that, the above portion is the line segment. So in which if you take any point and join to minus 1 to 0 and 1 to 0, and that will subtend an angle pi by 4 for every point of it. Anyway, what we observe? Now, what are the coordinates of this point? On the y-axis? So on the y-axis, it is the distance is root 2. No, the distance from here to here is 1. From here to here is the radius of the circle in blue, that is root 2. So this is 1, this is root 2, and this point will be 0, 1 plus root 2. And what will be the coordinates of this point? The coordinates of this point is 0, 3. And very clearly 1 plus root 2, the y coordinate, is strictly less than 3. Therefore, C2 completely lie inside C1. Through diagrams you can say. Therefore, the circles C1 and C2, they do not intersect. So, mod z is equal to 3, and argument of z minus 1 minus argument of z plus 1 is equal to pi by 4. They do not intersect. That means they intersect nowhere. Therefore, our answer is option C. That is the complete discussion of the solution of the problem through various methods of arriving the answer, right? And I am sure that you have understood the solution of this problem, and I wish you all the best. Thank you.